Simplify by adding or subtracting. So here we're going to be adding or subtracting radical expressions, and the key to this is that you can only add or subtract them if the radicand, the number underneath the radical, is the same. So looking at number 3, we have negative 2 times root 18 minus root 18. So what I need to look at is, are the radicands the same? So here we have 18 and 18. These are the same. That's easy to deal with. So what I can do is I can go ahead and add or subtract these, and here we're going to be subtracting. And if it helps, try and think of this root 18 as almost being like a variable. So what if I said negative 2x minus x? Well, that would be easy enough. It's negative 3x. Here we're just saying negative 2 times the square root of 18 minus the square root of 18. Well, it's still just going to be negative 3 times the square root of 18, just like that. So all I did was I said I had negative 2 of these minus 1 of these, so negative 2 minus 1 is negative 3 times the square root of 18. Now we can simplify, now that I've added or subtracted this, I can simplify that further by getting a prime factorization of 18. So when I do that, I find that 18 is 2 times 3 times 3. Notice that there is this 3 that I can circle and pull to the outside. So I get negative 3 times the square root of 2. So this whole thing is equal to negative 9 times the square root of 2. So multiple steps, I had to add or subtract, and then simplify what I had from there. All right, let's look at number 4. Negative 2 times the square root of 27 minus 3 times the square root of 3. Now, I cannot add or subtract these because my radicands are different. So what I need to look at when I have this situation is, can I get them the same by simplifying one or the other? Now this one won't simplify because what we have under the radicand is prime. This one, however, can be simplified. So let's simplify just like we did in the last set of problems. Negative 2 times the square root of 27. So that's negative 2 times, and now we need the prime factorization of 27, which is 3 times 3 times 3. And I'm going to rewrite the rest of this to show that nothing's really changing here. I'm just simplifying this one. So now there's a group of 2, and I can pull to the outside. So that gets me negative 2 times 3 times root 3 minus 3 root 3. Negative 2 times 3 is negative 6. Now I'm in a position where I can in fact do this. My radicands ended up being the same, and so I can take negative 6 minus 3 would be negative 9 times the square root of 3. And there is my simplified version. I didn't put my answer here in a box, but there you go. Again, all I had to do was make sure that these radicands were the same before I added or subtracted, and so that might mean simplifying something. And this can't be simplified as this is prime. All right, let's look at number 5, and I'll copy it down here, and then we can move to give ourselves more space. Plus 3 root 6. All right, in this case, neither one of these are prime, so I need to simplify both of them. So that means I need to get the prime factorization for 54, and that's actually going to be 2 times 3 times 3 times 3. I'm sort of doing these quickly just to keep the problem flowing. You'll have to take these and find the prime factorization for each one. Plus 3 times 2 times 3. So we see once we break this down, even though it's not prime, we can't simplify it because we don't have any perfect squares in there. So let's break this out so that we get negative 3 times 3 times 2 times 3 plus 3 times 2 times 3. and simplify everything back down, condense it, so we get negative 9 times the square root of 6 plus 3 times the square root of 6. Now our radicands are the same, and we can add these. Negative 9 plus 3 is negative 6. So my simplified answer here is negative 6 root 6.